Okay, now it's time to talk about how to turn our ERD, our entity relationship diagram, into a relational schema, which is one step away from actually making the tables in the database. In other words, it's a written out form of what our tables are going to be. Then we would need to translate them into SQL or some other methodology to do the creating of the tables in the actual database. All right, so how do we go from a diagram to a schema? We'll break this down into the parts of the diagram. So we've got our strong entity sets. These are simple. You just go ahead and you've got some table like users, and you take their ID and name. I love this type of table. All right, simple. Primary key, table name, attributes. Simple. You just go and you write the table name now, parentheses, ID underscore for the primary key you're copying, name, and parentheses. That's it. Pretty cool. We're not going to end up usually, initially in the initial construction of these, that will have attributes that are foreign keys. We will usually end up with foreign keys found in our relationship sets. When we get to a combination of schemas, so in other words, we can sort of reduce the number of tables that we have, then we end up moving things about and we can end up with introducing foreign keys into our entity sets. But on the initial pass, it's just a simple translation, right? The table name, note the primary keys, and so forth and so on. There, that's our first pass, and we converted our strong entity set to a schema. This is a way of us writing the schema, and it matches what the book does. It's very simple. I like it. All right, simple is good. So we just talked about weak entity sets. Now let's talk about converting them to diagrams. All right. What do we need to know here? One thing to keep in mind right off the bat, though, is we have to think about what it is that we're going to end up having as the primary key. Okay, so our primary key that we're going to want to have, so this is the primary key of the weak entity set is equal to the primary key of strong entity set. We already said this, but just to be really clear, strong entity set plus whatever those discriminating attributes are of the weak entity set. And then note that the primary key of the strong entity set is a FK, a foreign key. Okay, so I'll use FK everywhere rather than spell out foreign key, just like I like to use PK for primary key rather than spell out primary key. So in other words, when we're going to end up with a primary key of the strong entity set using it, and it's going to be a foreign key. So let's take this and go into the examples here. So we're going to take our insurance policies. All right, and again, we've got our policy number and our owner. Policy number is the primary key. And then we're going to, again, we've got this relationship here, which was policy dependent or DEP. It's a double triangle, diamond, total participation of dependents. And we have our discriminating attributes, name and birth date. All right, this is where I wish I could copy and paste on a whiteboard. Anyway, so we've got this guy up here. Now we're going to translate it into schema. So let's just start. We take the strong entity set. Okay, so that's easy. We write the table name, or the entity set name. It becomes the table name. So insurance policies, policy number. Oops, not done with that yet. And then its primary key, it's underlined, and we have owner. Then we go ahead and we'll take our dependents. It's going to be a table, so it's written, that's easy. Then take that primary key of the strong entity set and write it in policy number. And it's part of the primary key, so we're going to underline it. And then we're going to have name and birth date. They are part of the primary key as well, and so we underline them too. Okay. Now, we noted that this guy comes from here, so this here is a foreign key that references this one. So what we'll do is we'll say we want to make note of this somewhere nearby, so we say we've got a foreign key, which is policy number, references or refers to insurance policies dot policy number. Basically, it's kind of like we're writing pseudocode for how to create the table. So we'd be making this table here and specifying that this attribute is our primary key. Making this table with these attributes, would say them all together, they form the primary key. And then we would also make note to the database that we have a foreign key constraint, that our policy number refers back to the policy number in insurance policies. All right, and then we could also make choices such as on delete cascade. So if we made this foreign key constraint with a requirement that when it's deleted from here, it also deletes from here, that would mean we've added a on delete cascade part to the foreign key constraint, so that we would never allow dependents to hang about when we deleted one of these. Now the foreign key constraint would prevent that. But by putting the on delete cascade there means we don't have to first delete the dependents and then delete the policy. What we can do is we can just delete the policy and then the dependents get wiped out as well. All right, so those are our how we draw strong entity sets and weak entity sets. I have not yet covered how to handle this relationship set in here. Okay, so we're going to now talk about how to draw relationship sets. And we got to wipe the board again. All right. There is a bit more to figure out for relationship sets. One of the things to keep in mind, you're going to see it right now, but students seem to forget, is that relationship sets become tables. Okay, just because we don't draw them with squares in our diagrams does not mean that they don't become tables in the database. They do. So relationship sets, how do we do this? The thing to note first off are what are the attributes going to be of these relations when we make them? Well, they happen to be the primary keys of, so this is for relationships these are binary relations. Well, I'm not ever going to talk about the ternary ones where we have three interconnected. I'm always dealing with the ones where we've got a relationship set, and we have a relation A that relates to entity set B, like we've shown in the previous lectures. So the primary keys of both entity sets. So again, we have the relationship connecting two of these. It's a binary relationship, plus the attributes, if we have any, of the relationship. Okay, So we're going to grab the primary keys from the entity sets that we're connecting with this relationship, plus any other attributes that we had on the relationship, and those become then the attributes of the relation for the relationship set. All right. But how do we pick the primary key of the relationship set? All right, that we have got some simple rules for determining the primary key of the relationship set. So our primary key rules are pretty simple. If we have a many-to-many relationship, then our new primary key is the union of the primary keys. So we're getting primary keys from both entity sets. So if we have a many-to-many, we take them all together in the relationship set and they become the primary key then of the relationship set. We need all of them. All right. Now, if we have a one-to-one relationship, this means that we can pick either primary key to be the primary key of the relationship set. So you're going to have them both in the table, but you get to pick and declare whichever one you want arbitrarily to be the primary key. You don't pick both of them, you only pick one of them, and you only need to pick one of them. All right, that's easy enough. Then we have our many-to-one and our one-to-many relationships. And for each of these, the primary key of the relationship set is the primary key of the many entity set. So that's on the many, it's on the side such that it's the, it's the one that's, if we have one-to-many, all right, then the many side is the one that we make the primary key. All right, let's take an example of this here. Okay, great. So we'll go back to good old instructors who have their own ID and a name. They are connected to students via the advisor relationship. Our students also get to have an ID and a name. Now, this version of the example, again, we change it up each time almost. So notice that often this example gets mutated for whatever illustrative purposes we have. So let's remember how we read this now. So we have, if we take one instructor, they are related to 0 or more students. So an instructor, it advises 0 or more students. A student has an advisor, only one, but at most one. So a student has at most one advisor. Why do we not say that they all have an advisor? Because we did not make this total participation over here for the students. So it is actually possible in this setup for students to not be given an advisor, and it's certainly possible for instructors not to be given any students to advise. Instructors can advise lots of students, but students can have at most only one advisor in this diagram. Woo! Okay. Our goal is to convert this into a schema. We already know how to deal with a strong entity set. Just take its name, becomes the name of the table. We've got a primary key, and then our next column. Same thing happens with students. Got its primary key and its column. All right, now comes the figuring out how are we going to actually do the relationship set. The nice thing is, again, we just take the name that we gave it, and it's going to be the name of our table. Okay. Now, we have to go back to those rules that identify how to pick the primary key. So we are going to have, well, first of all, we know that we're going to have in here this primary key and this primary key. This relationship set has no attributes on it, so there aren't any other attributes. So the two attributes we're going to have in here is the ID of the instructor and the ID of the student. We cannot name it ID, ID. So a nice convention would be, let's name this one in the singular an instructor underscore ID, and this one a student underscore ID. All right, but again, I said we have to figure out what the primary key is of this relation. All of our relations need to have a primary key so that they can be in first normal form. And we also need all of our attributes to be atomic. All of these attributes are atomic. Okay, so our rules again. If it's a many-to-many, it's a union of primary keys. Well, this is not many-to-many. One-to-one, it's either primary key. This is not one-to-one. It would need to have two arrows for it to be one-to-one, or to be many-to-many, it would just be two lines. All right, so it's not neither of those. Now, is it a many-to-one or is it a one-to-many? So let's go again here. If I have an instructor, I can advise 0 or more, so many students. One instructor goes to many students. Okay. What about a student? A student goes to one instructor. Many students go to one instructor. Okay. So yes, the one to many. All right. So if it's a one to many, we always need to know what is the many side, and that one becomes the primary key. Well, this is easy from the diagram side because the one without the arrow is the many side. Because we take from one instructor goes to many students. And many students map back to one instructor. So this is the many side. And you just need to look at the diagram. It doesn't have the arrow there. This one does. Pick the side without the arrow. Its primary key is the primary key of the relationship set. And I just drew it under the wrong one. Let's draw it under the correct one. Student ID. All right, so student ID is the primary key. Let's take a moment and check to see if our understanding of this is correct. So we're going to end up being able to join between instructors and students via this advisor table. All right, so it can be like select star from instructors, students, advisor, where, and we'll do some join on it. But now let's think about it. If I want to join and I want to find a individual row in this relationship set, what identifies an individual row? Well, certainly we always know that we could take all the columns and we would get a primary key, but that's not what we want. It's the situation that, remember, a single student has at most one instructor. So when we think about all the rows in this table, the thing that lets us get to, and we know that we won't have any duplicates, is the student ID. Because of this, because we have a single student here goes to a single instructor, all right? But an instructor goes to lots of students. So if we tried to use this as a key, it would fail because a single instructor can have lots of students, so it cannot by itself be the primary key. But each student has at most one instructor. So if we have a student in the advisor relationship table, it will be a unique row. And by making it a primary key, we will enforce this notion, okay? By not including this here, this says very clearly, we'll have one student ID, but we could have lots of instructor IDs. And this table then will be set up as we expected in our ERD diagram. Great, but we're not done yet. No siree, we aren't. Because these guys here are foreign keys, and we want to tell the world, we want to tell our database about our foreign keys. So we have a foreign key of instructor ID, which references instructors.id, and we have another foreign key in here, which is student ID references students.id. All right. Now we have turned this little teeny ERD diagram. This is the relational schema here. We've converted two strong entity sets and a relationship set based upon whether it was a many-to-many, a one-to-one, or a many-to-one and a one-to-many. We then figured out how to identify what the primary keys were, or what is the primary key, sorry, of the relationship set. We make sure that we note what our foreign keys are, and we did it. All right. Is there more? Well, there is. What to note? We talked about, we didn't cover this, the relationship set for the weak entity set. And part of the reason actually is to note, and the book spends a long time to say this, and then they eventually tell you, like in a single sentence, something along the lines that they say the relationship set for weak entity sets the relationship set for, I'll say a weak entity set, let's fix my English, is not converted to a table. Why? Well, it's not necessary. The reason is that all the information that we need is already in the weak entity table that we made in the schema, because we've gone ahead and we've put that primary key in there. We have total participation of the weak entity set in the relationship, and we end up with always one weak entity going to one strong entity. And as such, when we put that strong entity in the weak entity set, that's all the information we need. We don't actually, that is the relationship. It's captured in there. And so we don't actually need a table for that relationship set when we have that set up there. Likewise, it's important to note that there are no attributes on such relationships. If you have attached attribute to such a relationship that doesn't make any sense, that attribute would need, you just go and you would stick it in the weak entity set. All right, great. So that's how we convert entity relationship diagrams, ERDs, to schemas. But we're not done yet, because we have one last sort of optimization. It reminds me of when we learn fractions, and you learn how to put your fractions together, and then your teacher says, and don't forget to simplify. basically this section of the book called The Combination of Schemas is about simplifying your schema because you don't really want extra tables. If you just got extra tables in it that aren't necessary, you're just going to be doing extra joins, which just makes your life tedious. And so this is about where can we basically squeeze out a table and end up with fewer tables. All right. The big thing this whole section really, what it gets down to is the big one is that when we have a one-to-many, or of course a many-to-one as well, because it's just the flip depending upon how we drew the diagram, a one-to-many relationship, that has total participation on the many side. So this is the side without the arrow. We can combine the relationship schema. And when we say schema, we're basically saying the table. Okay. With let's say it's the many entity schema. So it's the entity schema that came from what's on the many side. So we can combine the relationship schema that we create with the many entity side. So let's go ahead, show this in an example here. All right. We're going to do the instructors and the students again, but this time we're going to set it up differently. We're going to require that students have an advisor, whereas before we had it as optional. And this notion again, that once we're making it required, is a notion that we have total participation. So we have double arrows here that connect us to our students entity set. All right, so now we have total participation. Every student in here must have one instructor. Okay, this is a one instructor goes to many students setup. This is the many side. We've got total participation on the many side, and they tell us we should be able to get rid of one of our relationship schema. So let's see how this works. So again, quickly, we create our instructors schema. We're just going to follow this in the normal process. We're going to make our students schema. Then we're going to make our relationship schema. Remember, when we make a relationship schema, we're going to combine the two primary keys plus any attributes. There are no attributes on this relationship. Again, we're not going to go name it ID. We're going to name it instructor ID, student ID. We're going to say, oh, which thing is the primary key? The many side is the primary key, so the student ID is the primary key. All right, so when we have this set up, next we say, oh, yeah, we're supposed to be able to combine this. And why is that? Well, we can combine these two because every student, the total participation, every student has a single advisor. So think about that. And we have a table for students here each row, which is one student, each student has always one advisor. Oh, why don't we just record the person's advisor in the students table? Exactly, that's what it means. All right, we can do that. So we take these guys and we write out so that we get a new students table, and we're going to get rid of the advisor table, okay, the advisor schema. So students still going to have a primary key of the student ID. Students still going to have the student's name, but now we're going to pull into it the instructor who is the advisor of the student. All right, so pull in instructor ID into here. Okay, this is still the only primary key because we're identifying a single student. All right, and again, we can still issue the same queries. If we want to find all the students who have a certain instructor, that's easy because we'll just select where the instructor ID is equal to what we're looking for, and then we'll find all those students who have this instructor. So it works. It's wonderful. When we want to find this student's instructor, all we're doing is looking up the student, and the instructor is bundled along with it. Fabulous. So, oh, don't forget, write down your foreign key. So we have instructor ID, references. Again, we're going back to the instructors relation. So instructors.id. All right. Wonderful. Now, the book goes on and says, not only can we combine schemas for a one-to-many or a many-to-one, what we can do, we can also handle situations where we have, for example, a one-to-one. We can also handle the one-to-many and the many-to-ones where on the many side, we don't actually have total participation there if we allow nulls. Okay, so I'm going to say that if we allow nulls, is not what we want. Okay, I would much prefer a situation where we do not have total participation on the many side, that we don't combine, we don't get rid of the relationship set. I would like the relationship set to actually represent the notion that there is no matching instructor for that student by there not being a row in the relationship set. That way, we can avoid issues with where are the nulls. Okay, what do we have to think about the nulls? Now you might go, but we have an extra table and I don't want an extra table. True, but I don't like nulls. I think that's pretty clear by now. Anyways, so you can do one-to-one if you have total participation on each side. So if we have one entity here going over to another entity on the other side, and we've got total participation, no problem at all. Just stick those primary keys as foreign keys in the corresponding tables. All right, done. All right, you can just go ahead and get rid of that relationship set then. Now, the book will note, as I just was talking about, that if you allow use of nulls, you can also reduce a one-to-one relationship that has partial participation in it. in MSCI 245, when I'm looking at the entity relationship diagrams that you make, when you are told to convert them to schema, reduce them to schema, the only place that I'm looking for you to squeeze out and simplify the relationship set is going to be in situations where we have total participation. All right, because that way the relationship set can continue to represent the no match without any necessary use of nulls. It wouldn't be wrong to continue to reduce and to say, yep, and then I allow nulls in these situations. It's a little bit more complex. I don't think, unfortunately, the schema notation that we have doesn't capture, do you allow nulls or not allow nulls? That's information you would somehow need to note so that you don't mess up when you go and you make your actual tables in the database. You would need to be like, yes, this is okay for this foreign key to be set null, which would represent, that we don't have a match with that other table across the relationship that we had set up. This sort of reduction is not the most critical thing, but you're going to see it in lots of databases. Certainly, it makes a ton of sense when you've got total participation and you've got a one-to-many relationship, and on the many side, yeah, it makes no sense at all to have that relationship set anymore. You will definitely always be expected to reduce and get rid of that relationship set in those cases. So cases where, yes, where you've got total participation and it makes sense, yeah, we're going to get rid of that relationship set. Otherwise, I would advise you just to keep them. And with that, we've basically covered what we have now in Chapter 6. We know how to draw our diagrams, and we know how to then convert them to schema. And those are the real critical things in the chapter. There's a whole bunch of other stuff. Again, go back to the video where I go over the reading. Okay.